Hello world and welcome to this fifth video in my series about creating an IK-driven procedural walk animation. In this video we're going to make our spider a little more sure-footed by actually having it place its foot on the ground each and every step. My name is Mani and I make games. Let's get to it. Now, as you'll remember, in our previous video, we completed the walk cycle so that our foot actually picks up from its start position and moves to its final planting position. But each time we get to uneven terrain, the foot would go directly to the foot placement target, which sometimes would end up being in the air. We want to prevent this by actually aiming for the foot placement target, but finding the closest spot on the ground to it. We're going to do this by using something called a raycast. Before we get started with the raycast, all the usual stuff, the Github link as well as useful documentation links are down in the description. If you feel I've deserved it, hit that like and subscribe. If you have any questions or suggestions, hit those comments for me. Let's break down the problem we're trying to solve here. Right now, every time we move our foot, we move it to our foot placement target, which is relative to our head. That means that whether or not we are going up or down, or if there's a stone or a piece of terrain in the way, that target's just going to move to its position relative to the head, and therefore the foot target is also going to move towards that. Now this isn't ideal, because if our spider is moving and let's say we get to a point over here, let's just pick up our head. Let's say we get to this point over here. Now suddenly our foot placement target is underground, which means that if we just go towards that, we will be putting our foot not in our mouth, but definitely into the terrain. This is not something we want. So how do we fix this? Well, we need to find a way to figure out where the terrain is and find the closest point to our foot placement target, where we can then move our IK target to that point. To accomplish this, we are going to do a raycast. Now, according to the Unity documentation for Raycast Hit 2D, a raycast is conceptually like a laser beam that is fired from a point in space along a particular direction. Any object making contact with the beam can be detected and reported. This function returns a raycast hit object with a reference to the collider that is hit by the ray. The collider property of the result will be null if nothing was hit. The layer mask can be used to detect objects selectively only on certain layers, which we'll be using in this example as well. So what exactly does this mean for us? Well, that means that we want to cast a ray or shoot our laser from a point above our intended landing spot, and on the way we want to hit the ground. Now that would mean either hitting the ground before we reach our foot placement target or after we reach our foot placement target. Let's set up a few things and then we'll jump into the code. Firstly, I've gone to my foot placement target. I've added a new empty game object called my cast point, and I moved that to be above the foot placement target. Our casting point will be where we start shooting our ray from, and we'll be aiming it at our foot placement target. Now in my code, I've added some variables for this. Here we have cast position. That's the transform of the cast position we created. Then we have our ray cast depth. That's how long the ray we're casting needs to be. And we have terrain layer, which is a layer mask. That's going to be to which layer our terrain is on. Let me show you that. If we go to any game object, it has a layer property. Now, Unity layers can be used for different things. I've included the documentation in the description, so go check that out. In our case, we want to put the terrain layer as our layer mask. That means that when we do a raycast, we want it to only return a result if it hits something that is on the terrain layer. If you don't have the layer that you want yet, you can go add layer, choose an empty slot, and give your layer a name. In this case, I've already created the layer called terrain, and I want my ground, which is over here, to be on the terrain layer. Choose the layer, make sure it's right. That means that if I walk over a plant or anything else, the cast is going to ignore that and only return a result when it hits this layer over here. Okay, back to the code. When we get to our final phase of our step, we are where we pass the high point and we are moving our foot down. We want to change what our next target's going to be. Now this used to be the foot placement target, but because we wanted to be able to hit the ground and not just the foot placement target, I've replaced foot placement target transformed as position with this get ground point, which returns a vector2 point telling me where the ray hit the ground. And let's look at that function. If we go down there, we declare a raycast hit 2D. I've called it terrain hit. And I say physics 2D raycast. This is the starting position where your ray starts from, which is from our cast point, which we've serialized. This is the direction of our ray. Now our ray is going to be going from the cast point to the placement position, and as you know by now, we do that by taking the start and subtracting it from our destination. Doing this gives us a vector2 with the correct direction. Then here we specify what the magnitude of that ray is going to be, or the length of it, with our ray cast depth. And then here we specify which layers it should be looking for. This is our layer mask. So if it hits anything besides a terrain layer object, it will not return a result. Now what happens is terrain hit will not be null, but you will get a null on the collider for it. And if you request the point property for terrain hit, you will get a point of 0.0.0. So be sure to check in your code for this and take the appropriate action. This is a little debugging tool that I've inserted here. The debug.drawRay function in Unity is almost the same as the raycast. It takes a starting position for your ray. Then it takes a ray which has a direction, same as here. But we need to normalize that and multiply it with our raycast depth to get the correct magnitude for our vector, or the correct length in this case. Then we tell it what color to draw the line in, and for how long it should display the line that it has drawn. So in this case, we will draw a ray of color white. We'll show it for 1 second. We'll start at the cast position and we'll point it straight down at our foot placement target, and we'll have the length the same as the ray cast depth. And down here, I've done a debug.log statement just to tell me what point the ray actually hit our intended layer. That just helps us, find out if we have any problems. And if we see our feet flailing around in the air, we know that it's pointing to the wrong point, and we can check what that point is. Now here, I've put in some code to say terrain hit.collider. If it's not null, that means we did get a hit. We return the terrain hit point. The point property is that vector 2 we talked about that tells us where the hit took place. Otherwise, we're just going to make our foot placement target's position our next position and return that. Now this is useful. Let's say you have your spider and it walks off the edge of something. Then instead of doing all sorts of strange reaching motions, it'll put its feet into its standing position and get ready for a landing. You might want to do this differently. It all depends on your final application. So let's go back into the editor and see how that works. Now that we're back in the editor, we select our IK target. We find our cast point, which we've set up here. Make sure we drag it in there. Then we set our raycast depth, which in this case I've set to 5. We make sure that the terrain mask is set to terrain. And we'll talk about this in a little bit. Now let's click start. Our foot placement looks good. Let's do a little walk here. And no more feet going through the ground. Now watch what happens when I pick up my spider. And you see the raycast going down. Now as soon as the raycast can't hit the ground anymore, defaults to its foot placement position, and it still does what it does in the walk cycle by only moving when it's further from that foot placement position. This isn't always ideal. We can change the code to fix this, or we can go here to our IK target and we can make our raycast depth a little more. So if we have a scenario where our spider would say fall off something, it would actually try to reach down to the ground and place its foot on the landing. This needs some tuning, but I'll leave that up to you for your specific game application. Now, it's no use having a spider with just one foot. So let's enable another foot and see what happens. I'm going to grab the bones for leg number 8. I've already created a placement target for it as well as a cast point. And I'll enable the sprite so we can actually see it. And the IK target so we can move it. Let's press play. Our feet go to their positions. That's good. Now let's see what happens. Oh, I've never seen anybody walk like that. Our spider's jumping and putting both legs in the air at the same time. Let's fix this quickly. And what we want to do is to wait while one leg is on the ground. We can lift a leg, but if one leg is not planted, the other leg should not lift. So we go into our code and we make some changes. Now, first thing I've done is I've taken the step phase variable that tracks the phase of our step and encapsulated that into a public variable called current step phase, which has a public getter but a private setter. Then down here where we check if we should initiate a step, I've added one more line, which is this. This is opposing foot, which is a variable I've set up here. Foot mover, opposing foot as a serialized field. If the opposing foot's public property current step phase equals planted, then yes, let's select our new target and start moving. If not, wait. Now, let's save this and we'll see how it works. There we go, feet in place. And there we have a much more natural looking walk. Now I want to show you one last thing here. If we keep walking and we get to a steep incline, you'll notice two things. Firstly, my spider's body is not matching the gradient of our incline. It stays in the same rotation. And our raycast actually fails. This is something we need to fix, and I plan to do this in the final video of this series. But for now, my name is Mani, and I'm saying goodbye.